Hey, what's going on, guys? Xiangqi here. So since the last video, I've cleaned up the code a little bit. So now I just have this kind of stack map that allows to see how to reference the certain local variables that has been defined within my search function for a chess engine. And now instead of just pushing and pulling values many times, I just adjust the stack pointer like this. So the value of the stack pointer goes to X register goes to A register, then setting carry flag to make sure it works properly, then adjusting the value in the A register, putting it back to X, putting it back from X to the stack pointer, and that's how we shift the stack pointer. So it results in exactly the same stack frame being created on a stack, just like I've been demonstrating in the previous video. And same for return, so I just adjust the stack pointer but to the opposite direction basically. So here I was subtracting 2 because stack in 652 stack is growing downwards, and here on the contrary I'm just restoring back by adding the values to the stack to make sure it points to where it should be the return address, and then we just return the return address and we're done. And in this video, and yeah, and also I have commented out. So now the problem is, it's not a problem really, but now since we need to, like, let's just go back to the prototype. So here, once we've defined all the variables, I skip this part. So here, if depth is equal to 0, just return for now. I skip this entire evaluation part, so I'm not interested in this at the moment. Instead, I'm going for a mode generation purpose. So here, the major loop is the loop over all of the board squares, and within this loop, so it ends here. Within this loop, we need to decrease the depth by 1 and make a recursive call, right? So this is what we got here. So this is the loop over the board squares. And here we'll loop back in case if we didn't run out of squares, and then here we're going to be making our call here. But here, if I just try to run it like this, it's going to be done 128 times, and it's going to be extremely slow. So the screen would just light down for a while, and then light up back. So you can just trust me that it kind of works, because no reason really to demonstrate you that, because with this value it's going to be too slow. But what I want to show is how exactly I do reference the local variable called the source square. And remember that the source square is available on the stack pointer plus b, or stack pointer plus 12. Stack pointer plus 11. I'm sorry. And there we can manipulate that value. So what we're going to be doing here. So we're stepping into this loop over the board squares. So taking the value of the stack pointer to x, then the value of x to a. So now a contains the value of the stack pointer, clearing the carry flag, then adding 11 and putting it back to x to initialize the offset, and then we increment the source square in a current stack frame, and then we loading the newly incremented value back to a register to compare it with the hexadecimal 80 is in decimal is 128. That's the number of squares in hexadecimal 88 board representation. So we need to make sure that we didn't yet run out of squares. So if it's not equal, if a is not equal to hexadecimal 80, or in decimal 128 in this case, branch not equal, so it's not equal to this value, we loop back to square loop, and we do this exactly 128 times. Or 127. It doesn't matter, because the last squares are off board anyway, so this doesn't really matter that much. You could probably make the constant a little bit less, like to speed up the process a little bit, but anyway, it doesn't matter now at the moment. Just for clarity, I keep it like this. So what we're going to be doing now is I want to before anything else, let me just assemble the code and upload. And like without this loop, I just want to make sure that it just 208 hexadecimal, which means that it drops here, which is okay. So it doesn't stack, so it's still Yes, everything is working. So now I'm gonna be adding the break statement here. So every time we enter the loop over the board squares, we're gonna be inspecting the memory dump, and then trying to run over this loop step by step, like run, then again, and so on. So let's just assemble the code one more time and upload 0200 and run, and we are currently here. So let's have a look at the hex dump. So 0x 100 hexadecimal, where this stack starts in K1 in particular. So here we have the address where the search has been called from, the current depth, and here is the source square. So currently it's equal to 0 because we have initialized the source square to 0 and stored it there, right? So we did this before. So just before with the starts, we need to make sure that the source square has been initialized to 0. And now, well, since the address gets shifted just a little bit, if I just say here 02, 2 6, nope, probably, yeah, 7 8. So yeah, so this is 0 2 2 7 plus 1. So here, if I now press the go button, this would get executed one more time. So let's go for this. So executing the this loop over score one more time, and now again, so 0x 0100, 0x 0200, all right. And now you see like our source square has been increased by 1. Now it's equal to 1. So now we'll do this a few times just to give you an idea how this works in a loop. So 0228 and run, 0228 and run, 0228 and run. So it should be, how many times that is? It should be 4, right? So let's have a look. 0x 100 hexadecimal, 0x 200 hexadecimal. Yeah, now the source square is equal to 4. So far so good, but I'm not going to be doing this up to 128 manual because you just, yeah, can get crazy about this. So instead I just need to, again, change this value directly, just right in the memory to show you how this is going to be working. So the absolute address is 01F 01234567 8ABCD. So 01FD should be equal to 4. 01FD, nope, maybe I just miscalculated. 01FC maybe, yeah, 01FA, yeah, this is it, 01FC. So here I'm going to the data mode and let's make it to, let's say 7E. 7E, and now let's have a look at the hex dump again. So 0x 200s, and now we have 7E here. Okay, so far so good. So if we go back to 0228, what have I done? Sorry, get back to 7E, going back to address 0228 and run, and this now should be 7F 0x. Now this is 7F, and the next run the program would actually exit, and it would drop here, because now when I run the loop one last time here, now this condition, if the value of the A register is actually indeed equal to 800 hexadecimal, it's actually equal, so branch not equals is not going to work. So it just not dropping back to square loop. Instead it goes further on, and further on we have the return statement. So we'll just return and go to where all this stuff has started from. So if here I just say 0228 and run again, it goes to the initial address where it usually drops. So just to give you an idea, well, let's have a look at the hex dump. 0x 1 2 0x 200s. Yeah, it's actually got overwritten by stub because it just returned back and stack frame has been destroyed. But just to remind you this address, so if I just get rid of this break statement again and assemble and upload and try to run this normally, this is the address where it normally ends. So this is how we know that actually this kind of loop over the squares is actually working. Now probably one last thing, so we still can make this recursive calls. Well, I'm gonna be inspecting this because it's just I've been doing this in the previous video, and also if I do this like 128 times, it's gonna last forever. So I just make it like somewhere like this. It doesn't make sense from the chess programming perspective, but just in order to avoid this display build being dead forever. So assemble, upload, and 0 to 0, 0. So now it kind of do this stuff recursively, and now it will go back, and now it goes back. So, well, obviously, it won't be done like 128 times. It would be done the number of moves, and we don't yet have the number of moves because we just have a loop over all the board squares. And obviously, the number of moves is less than the overall number of the board squares. So I hope that makes sense. And probably this is it in regards to this video. So the next thing to consider, I believe we'll probably already start working with the variables. So we're going to be detecting the pieces on the board. So this is the actual board, and these are the p-squared tables to get the positional evaluation. And once we're done with detecting the pieces of equal to the side to move, by the way, yeah, from now on we actually need all of these variables. Because they are gonna be getting involved within the program. So yeah, starting from the next video, hopefully we'll already start working with this whole lot of variables and actually continue creating our mode generator in 6.5.2 assembly. That's it from my side, guys. Thanks for watching. Until the next time, and take care.